The graph shows the amount of water remaining in a tank after a leak occurs. So notice on my y-axis here, it's labeled A, probably for the amount of water in the tank, and it's measured in gallons. My x-axis is labeled H for hours, and that stands for the time since the leak occurred. You're going to have to use the My Notes section of your book for these questions, which is the graph paper. Question 5 says make a table, so it doesn't have to be super fancy. It can just be a little T-chart. Question 5, to show the amount of water in the tank at 5 different times. So our time is going to go here, and let's do the amount of water here. So you could do like at time 0, how much water? 2, 6, this is 10, so there's 10 gallons of water. And then you could do like 4, I see 8, 12, 16, 20. So go ahead and fill in your table. How much water is left? And then it says use the graph to identify the zero of the function. And then you can pause the video, and I want you to answer question 6, please, and question 7. You can do it. Try your best. The zero of the function here is the x-intercept, and the x-intercept occurs at 20, 0. Use your table and the graph to write an equation. Ooh, an equation. So we could use y equals mx plus b. We need our n, which is our slope. We need our b, which is our y-intercept. Okay, or they use a and h. So let's calculate our slope here. What are we changing by? What are we going down? 10 down to 8. 8 down to 6. What's 8 subtract 10? We're going down by 2. Going down 2. Going down 2. Okay, what are we changing by here from 0 to 4 in our time column? We're going up 4, up 4. So my slope here is a negative 2 over 4, which is a negative 1/2. Let's see if that's the case on our graph. Oh yeah, I'm going down 1 box over 2, so negative 1/2. Okay, so my slope is negative 1 over 2 plus, what was my y-intercept or my starting point? And I can find it 2 places. Right here's my starting point, or right here's my starting point, my y-intercept. 10. Good. 10, 10. And did we lose question 7? Oh, it's right down here. State a reasonable domain and range. So domain, we're going to look horizontally from left to right. Let's scroll back up. So we start here at 0, and we go all the way to 20. This is kind of a refresher from domain and range in our previous lessons. Range, remember, we look low to high, up and down vertically on our graph. So low, we start here, and we're graphed all the way up to 10. Okay, although my graph or my coordinate plane goes up to 20, my line starts at 10. So I need to say my range value is 10, not 20. So the amount of water is from 0, which means there's no water remaining in the tank, and 10.